divide and conquer algorithms also. Okay, how the divide and conquer strategy is going to work, we have seen very clearly in our last videos. So now we have to talk about, okay, so the next level of algorithm, which is nothing but searching algorithms. We have to talk about the next chapter, which is nothing but searching for the given data, searching for the given data. So what is this particular chapter? Searching operation. Here we have to perform searching operation. What is mean by searching? Very simple, sir. Searching, okay, searching is the process of finding. Searching is the process of finding an item or an object or an element. Searching is a process of finding an element or object, okay, so or an item in a collection of items. In a collection of items, it can be an array or it can be a list or anything. Okay, so here the item may be, okay, the item may be a keyword in the file, or it can be a book in library, it can be a book in library, or student record, so in database, etc. Anything, it can be anything, sir. So how we can able to identify, etc., or an object in list, etc. Like this we have we are going to define the searching. Sir, there are two ways are there to perform this searching operation. The following are the two methods existed to perform search operation. Sir, I want to do search operation. So there are two ways are there. What is the first one? You know very well. We have linear search algorithm is there. The second one is nothing but what? Binary search. There are two types of search operations that you can able to perform. One is what? Linear search. Other one is what? Binary search. So what is the purpose of linear search? Continuously, we are going to take the element. For example, if your elements are something like, if you have 5, okay, and then something like 1, 2, 3, 4, 5, like this if you have, so then what we are going to do, we will take the key element. Key means the element which you want to search. For example, if they have given key as a 3, what we are going to do, we will search for the data in each and every location. So first we will search in the first location, the data is not matched, so we will check in the second location, the data is not matched, we will check in the third location, the data is matched. The output what we are going to get is nothing but the value key is located at the second location. This is nothing but output. Sir, okay, binary search means what? If you have elements in this style, like 0th location, first location, second location, third location, fourth location, the key which you are trying to search, we will calculate a middle value in this particular list. Okay, so here if you calculate a middle, we are going to get a second. So directly we will search particular data in the middle location. Sir, we got the result right, hence return the middle, the output will become second location. Sir, you have taken the numbers very conveniently, that's why we got in the middle. Suppose consider in the middle location the data which you are searching. Assume I'm going to take the value of key as a 1. So this key 1 is not available in the middle location. Then what we have to do? Sir, we have two approaches are there for this. One is it can be present in the left side or it can be present in the right side. If it is present in the left side, we have to search only in the left part. If it is present in the right side, we have to search only in the right part. Do you know? So a big list is divided into two halves. By means 2. That's why it is called as a binary search. Sir, not only first time. Again, if you have this, so in the beginning somewhere I told, if you have 100 elements, it will be divided into 50 elements. Our next comparison will be with the remaining 50. In that, again, we will find out a middle element and we will reduce that to 25. Again, we will reduce to 12. Again, we will reduce to 6. Then 3. So then 2. Then 1. So 1, 2, 3, 4, 5, 6, 7. 7 comparisons we are going to do to perform this operation. If you have how many elements? 100 elements. So in the linear search, continuously we have to search. I think the outline of this particular linear search and binary search, I explained very clearly. Now our task is to just to write the programs. Beyond that, nothing is there. Can you please confirm everyone? Do you have any doubt in this theoretical approach?
No, sir.
No, sir.
Is it clear?
Yes, sir.
Yes.
Right. Right. So now we have to implement programs for this. The response is coming only from few students. I request everyone to please respond. So now we are going for the implementation of these programs. Sir, what is the first example that I'm going to cover in this? I want to implement linear search. I want to implement linear search algorithm, sir. So how you can able to implement this linear search algorithm? Directly, I'm taking the program and let us see how we can able to work with that. So I'm taking test.py code. Now consider I want to take a list where the elements are so 10, so 30, and then 90, okay, and then 20, and then 50, and then so 80, and then 70, and then 60. So all the elements are covered, right? 10, 20, 30. So 40 is not there. 10, 20, 30, 40. So 50, 60, 70, 80, 90. Yes, every element is available. Let us take 100 also. Now my requirement is I have to implement a searching algorithm. Consider I'm searching for 10. Okay, I'm searching for 10 in the formatted string I'm printing. Okay, so I want to search for 10 where this 10 is available. Can you please call linear search? Can you please call linear search by passing the given list and then 10? So since it is a function call, I'm going to put in within parentheses. It is going to return where exactly that particular element is available. If you want to before that, you can print the list also. Now let us cross check. So I'm going to define a function called linear. I'm going to define a function called linear search, which is going to take a list and it is going to take key value. So initially, what I'm going to feel is I'm going to feel the initial index value is nothing but -1. The initial index value is nothing but -1. Then for each I value in the range of length of list, I will find out the length of list. Every time I'm trying to check whether the element key which you have, is it available? Okay, the element which you are searching, that is a key value, is it available in L of I or not? We are checking. If it is matched, simply we are going to return the value of index. Sir, this loop got completed, but I have not got that index. Then what is the value of that particular? I think index value also is not required, sir. So can I return I value directly? Yes. If the element is not available, I can return -1, right? So this is nothing but what we have. So let us try and let us cross check. So consider this is my list, right? Assume I am searching for the value of key is equal to 40. First, it is going to check. Is it available in 10th location? I mean, is it available in 0th location? No. First location? No. Second location? No. Third location? No. Fourth location not available, fifth location not available, sixth location not available, seventh location not available, eighth location it is available. So what will be output of this particular program? It is going to return 8 if you are trying to search for 40. Sir, I'm searching for 120. Sir, it is not there in the first location to 8th location. Even I searched for 9th location also, it is not there. So my loop completely executed, but I found that that element is not available. Then what will happen? So my last return statement is going to execute, which will return -1, saying that element is not available. Let us dry run this code really whether it is going to work or not. We have to cross check by execute. So I'm trying to compile this particular program. I'm trying to execute. You can see we have tested.py. So the element 10 is available at 8th location, but here I have to change the element 120. Sir, it is not available in the list. So the output which we got is nothing but -1. This is the way, sir, how you can able to print. I think you people got a very clear idea. So how it is going to work. Can you please confirm is the linear search, how it is happening? Is it clear for everyone? Please confirm everyone how this linear search is working. Is it clear? If you want, let us take a few more cases. Like I will take 50 and I'm trying to take a 55. So what output we are getting? The element 50 is available at which location? 0, 1, 2, 3, 4. In fourth location, it is available. Okay, in fourth location, it is available. But if you see the element called 55, so it is not available. Simply it is going to return -1. This is nothing but what we are going to get. I think you people got very clear clarity. So how it is going to work, sir? Can you please confirm everyone? Is the concept of this linear search, is it clear for you people?
Yes, sir. Clear. Yes, sir.
Right. So we can write a conclusion here. What is the conclusion here is, so one small note. So if we want to apply linear search algorithm, if you want to apply linear search algorithm, the list can be in any order or need not to be in order, sir. Need not to be in order. Happily we can able to do. Sir, this is first occurrence, right? Implementation of linear search algorithm. If the element is available, I'm going to return its index. Sir, now I want to implement a linear search algorithm. So to return first occurrence and second occurrence, first occurrence and second occurrence. Okay. So like this I want to do. How we can able to do? Very simple, sir. I'm going to return like this. So consider I want to execute the code. Okay. Like in this, there are multiple 20s are there, or I have multiple 10s are there. I want to return all the locations of this 10. All the locations of this 10. Sir, how we can able to do this? Very simple. Assume I'm going to find out. So I'm going to call. So print off. I want to search for the data called 10. So what is output that we are expecting? I'm calling linear search. I will pass the list and 10. But a linear search. So first and second occurrence. Linear search. Let us write it as L search. So first and second occurrence. This is nothing but what we have. This is my function name. Sir, how to return first occurrence and second occurrence? So compulsory you need to take another list, some temporary list I'm taking. Initially my temporary list is empty, and here instead of returning, I'm going to append that value in the temporary list. That index value I'm going to return in the temporary list. Sir, at last you can return so 0 colon so 2. What will happen? It will return the index values from 0 to 1. So even if you ignore this 0 also no problem. So it is going to return multiple occurrences. That is first two occurrences. You can see the 10 is available in 0th location and second location. Sir, what will happen here? Suppose consider I want to perform this operation to search for the data called 80. So we don't have multiple occurrences, right? We don't have any multiple occurrences. I think we have only single occurrence. In such a case, what will happen? It will return only one element because we know slice operator is not going to raise any error, right? Slice operator is not going to raise any error. Happily, we can able to return. Okay. I think how we can work with this linear search algorithm for the data you got. Sir, let us see if I am taking any element, if I am trying to take any element, so which is not existed in the list. Sir, what will happen? What will happen? You can see we are going to get an empty list because the element which you are searching is not existed, right? The element which you are searching is not existed means simply it is going to return so empty list. This is the way how we can implement our linear search algorithm to return the first and last occurrences. I mean first and second occurrences. Everyone please confirm, is there any doubt in this approach whatever I covered till now? I request every student to please confirm any doubts up to this.
No, sir.
Right. Now, sir, my next case or next example, I want to take example number 3. What is the third example? I want to implement linear search algorithm to return all occurrences. To return all occurrences. So same application, right? I think instead of returning this, you can return the total list. So it is going to return all occurrences. For example, consider here we have another 80 is there. So in previously we got only one occurrence or two occurrences. Now you can see it is going to return instead of only two occurrences, it is returning all occurrences. This is the way how you can able to check, sir. It is a very simple. Just we are going to return the total list. I think you can change the function name like linear search. So all occurrences. Like this you can take. So what is my next scenario here is, so I want to implement linear search algorithm. So to search for or to return last occurrence, I want to implement a program to return the last occurrence value. Sir, how it is possible? How you can able to return the last occurrence? Linear search, I am taking last occurrence. Sir, you know very well, same list concept only I am going to use, but can I take -1? So in that list, if you take -1, what will happen? It is going to return always the last occurrence. It is going to return always the last occurrence. Like this, we can implement. Let us cross check list index out of range. Maybe if the element is not available, there we are going to get the problem because for first one and second one it is returning. For the last one, it is going to return like this. Sir, can we do one thing?
Slice operator we can use, sir.
Yeah, we can use slice operator. I am taking -1 colon. Okay, -1 colon. That means last element. So -1, and can I take -2 colon -1? So if you take like this, what will happen? It is going to start from -1 to so -2 plus 1. That means -2 -1. It will take -3. Okay, we have to stop at minus. Correct only, right? So if you have elements like this is -1, this is -2. I need from this location to this location, step value is -1. We will see whether we are getting two values or single value. Yeah, it is going to return only one occurrence, -1, 2. So ending index +1 it will take. Okay, -2 plus 1, which is nothing but -1, only one value it is going to return. So you can't skip this because we are moving in the negative direction. So compulsory we have to take this value. Then only it is going to work. This is the way how we can able to find the last occurrences. I think with this linear search, how we can able to implement,
Sir,
it is very clear for you, right?
yeah, yes, sir. Can we try -1 colon and then blank, -1 colon blank?
If you take -1 colon blank, what will happen? It is starting from -1. That is last location.
Okay.
Because of this particular, if you remove this -2, it will take up to beginning. It will take up to beginning, which will return all the indexes. Okay, and you can't take. You can't ignore this one. If you ignore this one, then again it is going to return empty values because you know. So whenever you are taking a negative direction, that is, if you are moving from right to left, so compulsory you have to provide the value for step. Otherwise, it won't work. Clear, sir? Sir, everyone, please confirm. Is it clear up to this whatever I covered till now?
Yes, sir. Yes, sir.
Right. So now my next application is nothing but we need to talk about binary search algorithm. Sir, what is this binary search algorithm? I explained in the very beginning theory itself. Just we have to continue with the program. Beyond that, nothing. I'm continuing from this example. So what is this example number 5? So implement binary search. Implement binary search algorithm. Okay. So to search for an element. To search for an element. Sir, I want to implement a binary search to find out whether the element is available or not using iteration. Using iteration. Iteration in the sense loops. Sir, we have to implement this particular algorithm by using loop. One more thing, one important note. So if we want to apply binary search algorithm, if you want to apply binary search algorithm, so compulsory list must be or data must be in sorted order. Then only we can able to implement either in descending or ascending, but recommended to take in ascending. Sir, how it is going to search? Let us see very clearly. Sir, here I am going to print the list. This is the original list. You can apply any sorting technique. Just I am using the predefined sorting technique. What it is going to do? 10, let us take 60. Let us take 20. So let us take 50. So let us take 80. Let us take 70. And let us take 90. So 20, 30, 40 is not there. Let us take 40. 50 is there, 60, 70, 80, 90. So almost all the elements came, right? So 1, 2, 3, 4, 5, 6, 7. Yes. Now the list is not in order. But anyway, my sort function is going to sort the data in ascending order. So now we can able to search in the middle location, right? For that, I'm going to write the program. See what will happen. If you perform the sorting operation, this is nothing but the output what we are going to get. So now the data which you are searching, I am going to write for your understanding purpose locations. So 0, 1, 2, 3, and then I'm taking 4, and then 5, and then 6, and then 7, and then 8. So the element which you are searching should be compared with exactly half of the element. So I will search by using which operation? Binary search. First, I will try to search for the data called 50. The data called 50. So in binary search method. So I will take a binary search 1, where I'm going to give the list and I'm going to give the key which you want to search. So better I will do one thing. Okay, better I will do one thing. I will read the dynamic value of key from the user. So enter key value. So enter key value. I think that will be good. So now we are going to provide the key value. It will search where that particular key is existed. Let us cross check where this particular element is existed. Now, how to implement this binary search function? It is going to take a list and then key it is going to take. Sir, make sure you have to take 2 extra parameters, that is low value, which is always a 0, and you have to take one more reference called high, which is always length of list minus 1. So 0th element is considered as a low and the last element is considered as a high. I told already, right? Now what we need to do, you have to calculate a middle value. The formula for that is nothing but low plus high by 2. Sir, now I got the middle element. What we have to do, you need to check the data is available in the middle or not. Let us write a while loop, because if the element is not available, we have to repeat the process. That's why if your low value is less than or equal to high value, then I'm going to check, I think better to calculate this mid value inside this. Now what I'm checking is the value that you are searching is available in the L of a mid location or not, we are checking. If it is available, I think we can return the mid value. If it is not available, try to check the element which you are searching is available in the left side of middle. If it is available in the left side of middle, then what is the meaning? So the element which you are searching is available here. Previously, we started comparing from the beginning to ending. Now you require to compare from 0 to up to 40. Sir, how to get the location of 40? Just now we have a pointer here, right? If you reduce that, will it reaches to 40 or not? Yes, that's why if this condition is satisfied, can you please tell me what code we have to write here? Is it low pointer we have to update or high pointer we have to update? Can you please confirm? Anyone? We have to change the pointer of high. What is its value? Can you please tell me? Mid minus 1. Okay. So now I'm trying to search for the element. So up to middle location I compared. The data is not there. This is low. This is high. Middle I compared. I found that the element which you are searching is less than this. Means the data is available in this part. Immediately this element should become mid, right? That's why high, right? Now you can look for this. That's why I'm taking high is equal to mid minus 1. Sir, I don't have here. Then definitely it will be there in the right part. I'm going to change the value of low will become mid plus 1. Because you need to search in the opposite direction. Like this, we are changing. That's all. Sir, I executed several times, but the element which I am looking for that is not available. So just better to return minus 1. So automatically what will happen? It is going to return the value minus 1 if the element is not available. That's all. Since we used a loop here, it will become iterative binary search. Beyond that, nothing, sir. Let us run this code. This is the beginning list after modification. Assume I want to search for the data called 50. So where it is available, sir? In the 4th location, right? Now assume I want to search for the data called 80. Sir, where it is available? 7. How it is encountered? Please listen carefully, friends. So this is nothing but my 0th location. This is the first location. This is the second location. This is third location. This is fourth location. So fifth location, sixth location, seventh location, eighth location. Case 1. What is the value of low here? 0. What is the value of high here? 8. So what about your mid? Because low value is less than high, your mid value will become what? So 0 plus 8 by 2, which is going to return, sir, 4. We are trying to search with the element which is available at fourth location. So is your key value which you are searching, is it available in the fourth location? No. Then the element which you are searching 80, so it is greater than 40. That means it is available in the right side of this. So second case, what will happen? We are updating low value to mid plus 1. That is from the mid value is 4. Fourth element we have searched. So we have to take low value is equal to 5. High value remains the same. We are going to get the updated mid. 5 plus 5, 10, 13 by 2. That means you are going to get a 7. 7 or I think 13 by 2 means we will get a 6 only. Now we are checking in the sixth location. So the element which you are searching is 80. So it is greater than 70. Again, condition is satisfied. So then what we are doing? We have to update low value as a mid plus 1. That is a 7. And your high value will become 8. Your mid will become, so 14, 15 by 2 means we are going to get 7. Now the element which is available at the 7th location is 80. And the element which you are looking is also 80. So what will happen? It is going to return the index. That is nothing but mid value. So in which location it is available, sir? 7. You can see how many comparisons we have taken. Almost 3 comparisons. If it is linear search, 1, 2, 3, 4, 5, 6, 7, 8 comparisons we have to do. Sir, if the value which I am searching is 100, then it is also not equal. Now what will happen? Your low value will become mid plus 1. Your high value will become 8. Mid also 8. We are trying to search for the data in this location. So since 100 is greater than 90, what we are going to do? We are going to change low value is equal to mid plus 1 and your high value will become 8. Now you can see low value is greater than or equal to mid means, greater than mid means we have to stop. So this is the way how my recursive binary search is going to work. If you are searching for 100, simply it is going to return which value, sir? -1. I think you people got a clear clarity how this binary search implementation is going to work for this methodology. For the given input data. Everyone please confirm, is the concept is clear, friends? Is the concept is clear, friends? Please confirm, everyone.
Yes, sir.
Right. Sir, same method. I want to go for implementation of this particular binary search by using recursion. Sir, once if you implement by using iteration, it will be very easy by using recursion because only functions we have to adjust. Sir, I will take the same program. So binary search I am taking 2, but make sure if you want to use recursion, compulsory you need to pass manually the low index value and also high index value. What is the high index? Length of list -1. So here also you have to receive low value and then high value, which is nothing but let us take the variables low and then high. Since you are giving low value and high value, we are not required to write these 2 formulas. So loop is not required, right? That's why I'm checking the base condition. By mistake, if your low value is greater than high value, then search is unsuccessful. I will return -1. Otherwise, what we are going to do, we will check the value. We need to calculate a mid value. So your mid value will become, as usual formula, low plus high by 2. So now what we have to do, you need to compare. Is our, so key value is equal to the list of a mid. Then we can return, it is also a base case. Sir, this condition is not satisfied. So we have the value of key is less than L of mid. Means what? The element which you are searching is available in the left side. Then we have to return. You need to call that binary search 2 by passing the low value as it is, key value as it is. Sir, when the element is available in the left side, you need to keep low value as it is like low, but your high value will become mid -1. Sir, when otherwise, if these conditions are not satisfied, then we are passing high value remains as it is. Just we are trying to change the value of low as mid +1. Have you observed? So same operation. So while low is less than or equal to high, we calculated mid value and we are comparing. If the element which you are looking is available in the middle, simply we are going to return that middle. Suppose if it is available in the left, then what I am doing? Sir, I am changing the value of high. By changing the value of high, again I am calling. So these extra things are not required, right? This is nothing but the advantage. So definitely it is going to give the correct results, I think so. Let me cross check. So I want to search for 30. 0, 1, 2 should be the answer. But you can see somewhere the problem coming here. I have not changed the function name. That is the issue. Now you can see. Sir, I am giving 30, 0, 1, 2. It is available in the second location. Sir, I am searching for 90. It is available in 8th location. I am searching for 88. It is not available, right? So hence, yeah. So that's why it is going to return -1. This is the way, sir, how you can able to implement binary search by using recursion. I think there is no change with recursion and iteration, right? So in the iteration, we are using loop. In the recursion, we are implementing the function in such a way that it is going to return the perfect data. So can you please confirm everyone? So up to this, whatever we covered, is it clear for you people, guys?
Yes, sir. Okay.
Right. So now my next approach, what we have, sir, I need to customize this. I need to customize this. That means, sir, example number 7, implement a binary search algorithm to search for an element. So in the first half, so in the first half only, I have to search. So means what? The algorithm is the same. I'm not going to change anything here. So I need to search only in the first half. So what I will do? So I will pass the key value as a 0. If I want to search in the half, so 8, how many elements are there? 3, 3, 6, 9 elements. 9 by 2 means where we are going to get 4. So first 4 elements within this we are going to search. So means what? You need to pass a length by 2. That's all right. Except that there is no change. Except that there is no change. Length of list is what? Sir, I think we are going to get 9. 9 by 2 means 2 4s are 8. 4 point something. Anyway, it will take 4. Since you are taking 4, it will take up to 3. That's why better to take this value plus 1. So what will happen? It will take up to 3. So in this part, it will search. So let us cross check how it is going to work. Sir, I want to search for the data called 30. It is giving its location. I want to search for the data called 40. It is giving its location. I want to search for the data called 50. No, it won't return. So, but it is returning 5, 4 because what is the problem here? 1 second. Let us check for 60. Is it taking? Oh, it is working for every element. So we are passing the value of I as length of list by 2 plus 1, right? Then why it is searching in the complete list? So let us give this value manually. I want to search in between 0 to 4. That means up to third location, it has to search. That means up to, so 10 we have to get, 20 we have to get, 30 also we need to get. So if you are giving 40, so it is giving 50, it is giving. So something is wrong here. Low value and high value we are passing. We need to search for this element in between this only. It is checking low value as a 0. Please cross check. High value is nothing but a 4. Is low is greater than high? Condition is false. We are calculating middle value, low plus high by 2. That is a 4 by 2, 2. We are checking whether it is available in the first half. So else, we are not using any length of the list, but again, why it is not coming?
Sir, do we need to save it, sir?
Already it is saved, sir. Multiple times I saved. Actually, we changed the parameters. For 60, it is giving -1. So for 50, it is giving 4. So what is the value that we have given? 4. So it will take up to 3. Maybe it is including the value it is taking. Because high value we are taking, right? It is taking including this. So that means, can I take length of the list by 2? Length of the list is 9. 9 by 2 means up to 4. So it is taking up to 4. Let us check now. It should work up to 50. We will try one more time. So for 10, it is giving 0. For 20, it is giving 1. For 30, it is giving 2. For 40, it is giving 3. For 50, it is giving 4. For 60, it is going to return -1. Yes. Now you can see the data which we have given is going to be searched only in the left part. I think it is very clear for you. Please confirm everyone. Is the concept is clear now? Please confirm. So if you want to search for right part, then what we have to do? I want to search in the second half. I want to search in the second half. If you want to search in the second half, same thing. In this place, we have to take length of the list by 2 plus 1, comma, length of the list -1. That's all. Now it is going to search in the second half. Sir, can I give 90? It will return its location. 80, it will give its location. 70, it is going to give its location. Sir, can I give 60? It is going to give its location. Can I give 50? No, it should return -1. Yes. So this is the way how we are going to search for range in the first half and then second half. Sir, if you are clear with this, tomorrow we will discuss customized range. We are going to give the starting value and the ending value. Okay, that we will see in the tomorrow's session. Can you please confirm, guys, whatever I covered up to this? Is it clear for you people? Please confirm.
Yes, sir.
Right. So I updated the running notes. Please cross check and try to practice, sir. So tomorrow we will meet for the continuation where we are going to see, we are trying to finish this searching and searching techniques. Okay. Right, sir. Thank you. See you tomorrow. I updated the running notes. You can cross check. Thank you, guys.
Thank you, sir.
Thank you.